The real number system. So as you can see, there are 5 parts to the real number system. If we start inside and work our way out, we have natural, whole, integer, rational, and off to the side here, irrational numbers. So if we look at this diagram along with the definitions, you can see that the natural numbers include just your counting numbers. So 1, 2, 3, 4, so on and so forth. If we move to the next grouping, we now have whole numbers. The only piece that's being introduced now is the number 0. So whole numbers include 0 and all of the previous category, your counting numbers or your natural numbers. So now you can see the examples I have are 0, 1, 2, 3, 4, so on and so forth. If we look at the next category, are integer. Integers are whole numbers and their opposites. So when we talk about their opposites, we're talking about the negatives. So positive and negative whole numbers, which include 0, even though there's not a positive or a negative assigned to 0. So we have -3, -2, -1, 0, 1, 2, 3, and as you can see, the ellipses on either side means it extends or continues on in both directions. Our next grouping is rational. So a rational number is any number that can be written as a fraction or a ratio. So that includes all of the natural, the whole, and the integers, because we can write whole numbers, as you can see over here, the whole number 7, as 7 over 1, so now it's a fraction, which makes it a rational number. We also have 20%, because 20% can be written as a decimal, so that includes a rational number, and all decimals we know can be written as fractions also. We have 2/3, so a fraction itself is considered a rational number. We have a decimal that ends, so 0.25 is a decimal that we call a terminating decimal, it ends. And we have a repeating decimal, 0.3, which also is a rational number because we can write repeating decimals as fractions as well. And our last category is irrational. So this is any number that cannot be written as a fraction or a ratio. So if it doesn't belong to these first 4 groupings, then we put it in this irrational category. So examples would be pi, 3.14, so on and so forth. That number never repeats, it never ends. We also have the square root of 2, which is also not able to be written as a fraction. And we have 1.24678, so on and so forth. The number's not going to repeat, it's not going to end. That's what these 3 dots or your ellipses tell you over here. So for this one, we're just going to categorize the following 6 examples. So as you can see here, for example 1, I have 1.8. So natural numbers are just your counting numbers, so you can't include decimals. Whole numbers don't include decimals, integers don't include decimals. So our category for this one is just going to be rational, because it includes this decimal place. If we look at example 2, the number 14. 14 is a counting number, so we know that it's a natural. However, it's also part of the whole number groups because whole numbers also include our natural numbers. It's also part of my integer because integers include whole numbers and whole numbers include natural numbers. And it's a rational number because whole numbers, like we saw up here, 7, can be written as fractions with a denominator of 1. So all 4 of these categories, natural, whole, integer, and rational, are included for example 2. If we look at example 3, we have 0.1234, so on and so forth. So since we have these 3 dots and I don't see any pattern here, there's nothing being repeated, that has to fall under our irrational category. We look over at example 4, 0. Natural numbers include counting numbers. Our counting numbers start with the whole number 1. So 0 is not a natural number. However, it starts with my whole. It's a whole number. It is part of the integer because integers are all whole numbers and whole numbers include 0. And it's rational. It's rational because 0 over 1 is still 0. If we look at example 5 down here, I have negative 180. So start at the top. My natural numbers are counting numbers, which are only positives. Since it's a negative, it can't be a whole number or a natural number. Whole numbers include 0 and naturals. So again, since it's a negative, it can't be a whole number. So now we move to our integers. So it is an integer because it is a whole number's opposite. It also is rational because it can be written as a fraction by putting it over 1. So in this case, we have 2 here. And for example 6, we have the fraction 2/3. So it's not a counting number, it's not a whole number because it's not 0, it's not an integer, a positive or a negative whole number, and since it's a fraction starting off, we know that it's a rational number. Now, I'm going to throw in an extra example because if you can simplify first, you need to. So if example 7 is 3/9, I can reduce 3/9 to 1/3. Therefore, this is still a rational number. If, for example, I have 12/4, 12/4 can reduce to the whole number 3. So even though it started off as a fraction, I'm really looking at this natural number of 3. So this is going to be your natural, your whole, your integer, and your rational number. So if you can simplify things, you need to do that first. The other little piece of advice is if you start at the top, if I know that it's a counting number, it's going to be all of these categories. If it starts with the whole number, so 0, it's going to follow and be the following 2. If it's an integer, that negative whole number, it's only an integer and a rational number. And if it's a fraction by itself that can't simplify into a whole number, then your rational number is going to be isolated.